Today we are going to be looking at a wonderful topic titled indices, and in this topic we are going to learn how to identify and use the law of indices, how to solve simple equations containing indices, and how to simplify expressions that contain product of indices and fractional indices. Before we continue, let's take a brief look at the introduction. Indices is the plural of the word index, and an index is the power of a particular number. When you have an expression written as x raised to the power of y, the y is the index and the s is called the base. And when we have the index form of 3 raised to the power index form as 3 raised to the power of 4, the 4 is the index and 3 is the base. We have an expression written as z raised to the power of 3, the 3 is the index and the z is the base. The law of indices are used to calculate expressions involving indices. And the first law says that when expressions with the same base are multiplied, the indices are added. Looking at our example, we are given 3 raised to the power of 4 multiplied by 3 raised to the power of 3. So the two expressions are in the same base 3 raised to the power of 4. They have the indices of 4 and 3, which means we are going to be adding our 3 raised to the power of 4 plus 3 to give us 3 raised to the power of 7. And going through this with another format, we have 3 raised to the power of 4. That is our 3 multiplied by 3 in 4 different places. That's 3 multiplied by itself in 4 different places, multiplied by another 3 multiplied by itself in 3 different places. And when you put that together, you get 3 multiplied by 7, 3 multiplied by itself in 7 different places to give us 3 raised to the power of 7. And this law is only applicable to expressions with the same base. When you have your expression in different base, you have your equation in different base, you cannot use this law. The second law says that when the expressions with the same base are divided, the indices are subtracted. The first law that we treated has made us to understand that one is for multiplication, and when the expressions are multiplied, you add the indices, the index. And now for the second law, when the expression with the same base are divided, you subtract the indices. Looking at the example that we have here, 3 raised to the power of 5 divided by 3 raised to the power of 3 to give us 3 raised to the power of 5 minus 3, which will be equal to 3 raised to the power of 2. And equally going through this with another format, we have 3 raised to the power of 5, which is 3 multiplied by itself in 5 different places, divided by 3 multiplied by itself in 3 different places. The numerator, which is 3 raised to the power 3, we cancel out with another 3 in different places to give us 3 in 2 places, which is 3 raised to the power of 2. Just as the first law is applicable to expressions with the same base, the second law is also applicable to expressions with the same base. You cannot use this law for expression with different base. Now for the third law says that when a number is raised to an index of 0, it is always equal to 1. This law is often referred to as the zero index law. Let us look at the proof, or how it got to be, how it came to a conclusion that any number raised to 0 will be equal to 1. We are given an example to start with, which is 2 raised to power 3 divided by 2 raised to power 3. This example, it is of a common base. The expression is in the same base 2. So we have division as the arithmetic operator in between them, and with this we are going to use the second law of indices, which states that when expressions with the same base are divided, the indices are therefore subtracted, which means definitely we are going to subtract our 3 from 3 to give us 0. But going through this with another format, it gives us 2 raised to power 3 to be 2 multiplied by itself in 3 different places, divided by 2 multiplied by itself in 3 different places. Now we are made to understand that 2 divided by 2 equals to 1, which is right. And when you multiply your 1 by 1, it gives you 1. So for all mathematical operation, for all expression, for all equation, when it is raised to a power of 0, when it is raised to an index of 0, it will always be equal to 1, because that number will be a number that divides itself to give us 1. The fourth law: when a number is raised to a negative index, it is always the reciprocal of the positive index. This law is often referred to as the negative index. Our example here states that 2 raised to the example the example stated down here is 2 raised to the power of minus 3. And in this example, you know that the index is negative. The positive index of 2 raised to power minus 3 is 2 raised to power 3, and the reciprocal of 2 raised to power 3 is 1. So the fifth law says that the final index. Here in the fifth law, let us look at this expression: open bracket x raised to the power of a, close bracket, raised to the power of b, to give us x raised to the power of ab. This is called the product of indices, in which every element inside the bracket is multiplied. In which the index in the bracket is multiplied by the one outside the bracket. And the example that we're given: open bracket 3 raised to the power of 2, close bracket raised to the power of 3, equal to 3 raised to the power of 2 multiplied by 3, to give us 3 raised to the power of 6. Now we have to be very careful with this law, with dealing with indices involving brackets. When we have our x, open bracket xy raised to the power of close bracket raised to the power of n, to be equal to x raised to the power of n, y raised to the power of n, this signifies that every element in the bracket take on the property of the index outside the bracket. We have our open bracket ab, close bracket raised to the power of 2. The a inside the bracket take on the property of the index outside, which is raised to the power of 2, and the b inside the bracket takes on the property of the 2 of the index, or rather the index outside the bracket, to give us a raised to the power of 2 and b raised to the power of 2. And also, considering this one, x over y, open bracket x over y, close bracket raised to the power of n, equal to x raised to the power of n over y raised to the power of n. Here we have the x inside the bracket taking on the property of the index outside the bracket, and we have the y inside the bracket taking on the index of the property outside the bracket. It doesn't matter whether it's a fraction or it's a whole number, or it's whatever it is. Each element inside the bracket takes on the property of the index outside the bracket when we are dealing with the product of indices. For the sixth law, this is the fractional index law. For this law is employed when you discover that your index is in a fractional form, is in fraction. The representation of this law states that x raised to the power of a over b equals to b root x raised to the power of a, where we have our b expressed as the root of x and a expressed as the power, as the index of x. A brief look at this example. Still, we have the example as 27 raised to the power of 2 over 3 to be equal to 3 root 27 raised to the power of 2. We have our 3, which is the denominator of the fractional index, expressed as the roots of the base, and 2, which is the numerator of the fractional index, expressed as the power of the base. Now 3 root 27 gives us 3, because 3 raised to the power of 3 equals 27. 3 root 27 gives us 3, and our 3 raised to the power 2, that one will give us 9 if we have to work it out. Another subtopic that we are going to consider is the index of an index. Index of index. Now, this is not very common, but when you see stuff, when you see expressions like this, you see question represented in this way, you don't have to be scared. You just have to take a deep breath and calm down and take it one step after the other. When we are dealing with index of index, we deal with the exponent at the top first. We deal with the index at the top first. This is 5. In the example, we have 5 raised to the power of 3 raised to the power of 2, which means we have to deal with our 3 raised to the power of 2 first before we go to the base. For the expression 3 raised to the power of 2, we have 3 as the base, which means we will be multiplying 3 by itself. 3 times 3 will give us 9. which now makes 5 raised to the power of 3 to the power of 2 to be equal to 5 raised to the power of 9, which will be 5 multiplied by itself in 9 different places to give us 1,953,125. Here in the table below, we have the summary of what we've been discussing ever since the law of indices, from the first law where we multiply expression in the same base, and in solving for that we add up the indices, and for the second law when we have an expression with the same base and they are divided, we subtract the indices. The third law, which is the zero index law, which has made us to understand that any number raised to the power of 0 equal to 1. The fourth one, which is the negative index law, states that when a number has a negative index, it is always the reciprocal of the positive index. And the fifth one, which is the product of indices, has made us to understand that whatever index that we have inside the brackets will be multiplied by the index outside the bracket, and whatever element you have in the bracket, it will take on the property of everything, all the index that is outside the bracket. The sixth law, which is the fractional index law, where we have x raised to the power of a over b. The denominator is expressed as the root of the base, and the numerator is expressed as the power or index of the base. That is all on indices.